Hi, everyone. So I'm Mikel. I'm working at ProbLab. We are basically focusing on metrics on the LP2P side of protocols with the idea of trying to make them better and probably optimal up to the standard that we want to have right now. So the talk of today is pretty much a summary of the research that we have done over the last years with the main idea of seeing like where are we now at GossipSub, which are the challenges that we are experiencing, and which are the proposed roads that we can take in order to move them forward. The disclaimer, this is my personal take, so there might be many other takes, so happy to have a discussion afterwards. But yeah, um, for those ones that maybe are not that familiar with GossipSub, it's pretty much the main way that LP2P offers to broadcast messages over the network. Is it a PubSub like protocol, which means that there might be many different topics, but you don't need to be subscribed to all of them. This allows you to disseminate and receive messages only on the things that you are interested at. GossipSub is a small, um, a slightly more efficient way of doing it. Like instead of subscribing and getting all the events, it allows you to have like a small representation of the network, which is what we call mesh. And you keep a small mesh for each of the topics that you want to have. And this is the way that you are kind of saving a little bit of bandwidth there. It includes several features with the idea of making it more resilient in order to facilitate like civil attacks and many other stuff. Those are what we call control messages. And the main idea is that we achieve resilience only by not only eagerly pushing messages to peers that we are connected to, but we do have also like a separate layer of lazy push where we notify others that we saw a message in case they didn't see it, so that they can request it from us. So it's been a long journey. We are now at the 1.2 version. This is the list, like the grand list of what I think is relevant to mention. We have dynamic meshes. Like I've mentioned that we have like a small representation of who are we connected to in the network, but this is not rigid. Like this goes and changes over time. We do share these I have said once on heartbeats, like every given period of time, we are sharing with other people that we are connected to, like which are the messages that we saw and which ones maybe the other one didn't get, so that we can have like this fluid conversation, filling gaps that the other peer couldn't see. We also keep a list of fan out peers, which is like, okay, I know that there are these peers in the network that they are subscribed to these topics, and I only directly connecting or sharing information with few of them, which are the messages. So the fan out peer is that we can still use or make available like all those extra peers that we know which topic are they subscribed to in order to receive from them or even push into a topic that we, by the moment we need to send a message, we are not using, or we cannot do it through our mesh, so we can do it throughout these found peers. It also allows like message validation. Like ideally, you don't want to propagate messages that are not validated somehow. For this resilience, like we also included like a peer score. Basically, if peers are misbehaving with you, you keep track of that to the point that if they go below a threshold, you can pretty much understand that that peer is not a good citizen in your mesh, and you can prune it and go for another peer on that connection. And the latest addition was the I don't want messages. We realized that GossipSub tends to be chatty in the sense like you are broadcasting to your mesh peers directly, which tends to create many duplicates. So an I don't want message was included there in order to prevent the like trying to be slightly more efficient, notifying others before they start sending us messages that we already received it. So it's been a long journey. Like GossipSub was pretty much designed at the early 20s, like maybe also the first versions were slightly before. But we have to keep in mind that we are currently having something really close to what was designed at the beginning. At the beginning, it was designed as a way of propagating messages, but with an idea of having them small enough so that the main focus was broadcasting, was not throughput, wasn't any other thing, but disseminating messages in a resilience way, on a way that no one can eclipse us. So we can see the meme on the left side, where it's like GossipSub was just a way of doing it, while the main focus was probably on consensus and many other things. So what we have now is that this protocol has come along to the point where we have many applications with many different ideas of how do they want to use it. And we see is that the throughput requirements that we are imposing into GossipSub are way bigger than what it can actually handle. As I mentioned, generally, there were few talks yesterday talking about the main restriction that we have now is broadcasting. It generally comes to the point of bandwidth. You can buy higher CPUs, but you cannot always buy like more bandwidth, or you cannot always have access to faster bandwidth or more bandwidth. So the idea is that we do actually see limitations in GossipSub because it's pretty much not fitting the requirements that we have at the moment. So yes, there are definitely limitations at the GossipSub level. And the main issue is that it's not a mess, but it's a complex system that we need to first understand in order to see how can we overcome these issues at the throughput level. So the main idea is that at the moment, it's quite rigid, which means that when a node, a client wants to set up a GossipSub instance, you can subscribe to many topics, but the parameters of GossipSub are for the service itself. And there are definitely multiple applications that it's using GossipSub for many different things across those different topics. An example of this would be, I'm mostly working with Ethereum, so the main idea is that you have some topics to disseminate attestations, which are really small messages, but that are happening on a large blast, like many small messages. And then they tend to go out of control because for those control messages that we are sharing in order to be resilient, what we end up is that we have a huge overhead exchanging control messages because, yeah, the parameters are kind of, if you think about the distribution, the parameters are set to be at the mean because we pretty much cannot distinguish them between different use cases. And perhaps like the most relevant thing here is also like the large messages. GossipSub wasn't designed to disseminate large messages. And now we are paying that price mostly because by the moment we are sending a large messages, we are already receiving them from others. In the end, we have many duplicates and we are saturating our bandwidth for just receiving a single copy, a single valid one. So yeah, the idea is that we should be thinking about overcoming all these issues. So this is totally to my interpretation. There are many things that I haven't put here, but there are different causes that I think are relevant to what we have now, and it should be the things that we should focus on in order to move forward. But they are not independent from each other because many of those things interact with each other and they are kind of leaving us where we are now. So the first one is the users. Like, I'm not saying that we should blame them, but there is definitely kind of feels like when blockchain was new and everybody was trying to put blockchain where there was not even a need, like we have to think about whether GossipSub is the right, like, okay, we might need to broadcast messages, but maybe we can do it more efficiently in another way. Like, so we need to understand what can it offer and we need to use it smartly. It has happened that maybe GossipSub was the right fit at some point, but then we have scaled it so much that it's becoming a bottleneck. So we need to play smartly around GossipSub. And definitely, it's a complex protocol at the configuration side. So users need to understand that they need to pay attention to these configuration parameters in order to get the maximum out of it. An example of this is something that even has happened to us, is that many people have been using GossipSub to propagate large or many small messages to the point that the validation queue, like the user experience is that you are missing some messages around. And the main reason is that your validation queue is filled up, so you cannot add anything else, and therefore you'll miss those messages. It's a simple thing that can have like a big impact in the application layer so that you stop missing messages, but it's still there, and there are still people facing the same issue. So from what we do at ProbLab, where we take a look at how the protocol works and we try to monitor it, we've identified like that there are still like not coding issues, but there are still edgy cases, timings, and misinterpretations of these specifications. What I want to say with this is that we should probably take a look at what we have now, pay attention of what are these identified edgy cases that are happening, try to see whether we can reduce them as much as possible and have like a solid background, like a solid base on top of which we can build like new features. Edgy cases that we found, for example, are that if a peer sends us a message through an iHave that we didn't see before, we are supposed to send with an iHave because someone has a message that we didn't see. The issue is that there is no limit on the number of I1s that I have to send. This is up to interpretation on the implementation side. So there are many things like that that you can find in the code, at least the code that I was reviewing. And there are definitely also many timings that incentivize these edge cases. Like something that we were able to see, for example, is that 60% of the I1s that our node was sending were happening like 10 milliseconds before we were actually receiving the message through our mesh. So we were, because of these edge cases and the timings, we are pretty much saturating our bandwidth in a way that we should be handling smartly. And the third one is misinterpretations. Okay, this might be like punctual stuff, but we found a bug in the JVM implementation where, so the specification says that if someone sends a message ID on an iHave, like someone notifies you that it has a message on a topic that you are not subscribed to, you're pretty much gonna discard that message because it's not of your interest. So the JVM implementation was pretty much adding all the message IDs in an empty string topic, which means that for 4 years they weren't getting used of I want messages. And no one realized it until we were actually paying attention at this level of tracing and at the coding level. So there is definitely a big improvement feel in this before we can actually move forward. And the third one would be like, yeah, pretty much on the lines of what I explained. Like there is it's not a coordination issue, but perhaps we should coordinate more efficiently. Like there is a single spec which is meant to be broad as possible so that implementations can choose whatever they want based on their needs. We have to assume that GossipSub is not used only for Ethereum and big projects, but by many other stuff. And those teams have been facing like their own problems and they have adapting their implementations to overcome them. But that knowledge hasn't been shared with many others. Or it has been shared, but we haven't been paying attention to actually learn from those. For example, like with the I don't want addition, it was something that the NIM implementation has already there for over 2 years, while it took us like 8 months, like it was implemented for the rest of the implementations like 8 months before. So, okay, we know where we are at. What can we do now? Like we know that we have a system that we definitely need to upgrade because it's not fulfilling the needs that we have now. But how should we do it? Out of this coordination, like most of the like extensions that have been proposed go over the same line, which is like because right now it's too rigid and you pretty much rely on the eager push, which is creating duplicates. The idea is that we should be able to handle our mesh in a more efficient way or in a more smart way. I've listed here a bunch of proposals and even implementations that are on the lines of, yeah, trying to combine the eager push to a small percentage of their mesh with the idea of having eager push, like people notifying you when they receive a message on a larger scale than the people that is doing like the eager push. Yeah, we can go in detail maybe in the questions of afterwards. Like I don't want to pay much attention. Like most of them are on those same lines. Like GossipSub is not working well with large messages, and the only way of making it better or scalable is pretty much like having these combinations of how to broadcast the messages. Okay, I want to take this like as the summary of the talk. It's like we do know what is GossipSub, how it works, which are the limitations, but there is definitely a set of common targets that I think are relevant in order to make it better. The first one is like we should shape slightly the specs so that we describe the main functionality of the protocol at the same time that we include like which are the best practices. Like all this knowledge from all these teams that have been using GossipSub and implementing it for many years, it should be shared across the spec or at least link at the spec so that others can understand, okay, I'm facing an issue where my node is receiving many duplicates. Why is it so? Maybe there is a mitigation technique already happening and I don't know. I know that the Rust implementation is playing smartly of how you queue messages over the wire. So maybe this is something that we should extrapolate to other implementations. Another thing, like there is already work going in to make it more parametrizable with the idea of let's make parameters per topic instead of per service. Like it's not the same handling attestations in 4 seconds that having to deal with many large messages like blocks or blobs in Ethereum. It's not the same. We don't need the same requirements. And the main idea is, once again, either which direction we take, definitely there needs to be an upgrade in GossipSub in order to make it able to disseminate those messages. Reducing the duplicates with a smart combination of eager push and lazy push, it's probably the way to go. There are many other low-hanging fruits like cell leveling messaging, which means like you can, instead of transmitting or broadcasting the message as a big chunk of data, maybe we have to chunk it and divide it into cells that are easier to broadcast, and you can play around to who do you notify them, and how can even you can apply erasure coding to actually recompose it without having the whole set. So yeah, this is pretty much my view on GossipSub. Hope I didn't disappoint anyone that wanted more details, but we can talk about them afterwards. So yeah, happy to take any question if others. Small disclaimer, like we at PropLab have many dashboards. Like there are even some dashboards that are monitoring GossipSub at the Ethereum mainnet level, which are updated daily. In case anyone wants to check them and come up with any questions, like yeah, feel free to reach out.
Thank you, Mikel. We actually have a bunch of questions here. I'll go through them via the most popular one, and if the question is a bit like ambiguous, we can just ask the question asker to write it again. So the first one is, when you say small or large messages, what kind of size do you mean? Transactions, blocks, hashes? Is it order of few bytes to kilobytes, or is it a few megabytes? I think this question was a bit early in the presentation, so it might be referring somewhere there.
Yeah, so I can talk about, I mean, this is pretty experimental. Like you don't know how big is something until you see how it behaves in the network. But for example, for I don't want messages, it was something clearly useful only for what we consider large messages. So the more it takes a message to propagate, the more time we are giving to receive duplicates, and also for someone to let us know that they have a message that we are receiving, but we didn't receive it yet. So we kind of agreed on a consensus for having like a threshold of 1 kilobyte. Everything above the 1 kilobyte was worth spending that message, like that extra RPC in order to consider it large. We also should maybe consider like super large, something beyond the megabyte, like what we used to, yeah. If the message goes beyond another threshold, probably we should be looking about chunking and sending like this cell leveling messaging. But I mean, it's hard to say like what is large, what's small. That's pretty much the consensus that we reached. At least at the GossipSub level, we consider something large if it goes beyond that threshold.
Okay. And the next question is, to how many topics can GossipSub actually scale? What is the overhead?
That's a good question. So we know that there are networks out there with, like Ethereum has over 70 topics. I guess this also goes on the throughput that you want to put at them. As it is right now, the overhead of GossipSub is shared across all topics. Like it will be different if we want to parameterize it. Yeah, like I don't know how to answer that question, to be honest.
Well, maybe we can go more directly to.
Yeah, sorry. Like maybe the right people to answer this is the Waco team, which are using many GossipSub topics for different application levels. So maybe those guys can give us more information there.
Yeah, maybe we can go to the next question, which goes more at the Ethereum context. From your perspective, which parts of the Ethereum protocol suffer most from GossipSub limitations, especially the ones that you mentioned?
Yeah, I mean, I guess the clear answer here is that now that Ethereum is pushing many blobs, like we can think about a blob as a large message with arbitrary bytes, which is cold data pretty much that is not on-chain. The idea of Ethereum is that they want to scale the number of blobs. And because they are large enough and they want to be sent in a small number of time, yeah, like GossipSub is becoming a bottleneck because it's pretty much draining the bandwidth that we have available at the network. So it's not per se a problem of GossipSub, because if we had enough like unlimited bandwidth and unlimited resources, like GossipSub wouldn't be the problem. But it's probably a combination of how the setup of Ethereum is in terms of the topology and the resources that they have available and the current GossipSub. Like, that's why I was mentioning like we should play a little bit smarter with how we compose a mess and who do we forward messages, because that could allow us to free bandwidth that we could be using to actually send more new messages.
And the final question, do you think the extensions are applicable more widely to all GossipSub users, or are these quite Ethereum specific?
So just for context, like not all the extensions that I listed there were proposed by people working with Ethereum. Some of them, like the preamble of I'm receiving, I want, like that was proposed by the NIM folks. So it looks like Ethereum is not the only one facing the issue of having to broadcast like many large messages. But it's true though that Ethereum is pretty much now getting more conscious about how we could actually reshape Ethereum to make it better. But once again, like just because Ethereum will benefit from it doesn't mean that anyone else can benefit from it. Like I guess that every other chain that now can broadcast sooner, like large chunks of data, can actually benefit. And maybe we actually see more use cases of GossipSub because of that.
Okay, awesome. Thank you everybody for, oh, there's one final question. Does 2D data availability sampling of blob play better with GossipSub since it would reduce message size? It's a very specific question, if you can answer it.
Yeah, I mean, okay, 2D, if you're erasure coding in 2 dimensions, yeah, you have like lower messages, which should have, but at the same time you have more messages. You have those extra cells that you created from erasure coding. So I guess we have to keep monitoring it. Like big shout out for ProbLab to keep doing it, maybe. Like.
Okay, awesome. If you still have some extensions to those questions, please catch Mikel in the hallway afterwards. Let's give him a final round of applause. Thank you, Mikel.
Thank you.